Welcome to part 2 of day 5 of the randomizer project, where we are continuing on our quest to build the game of Boggle. So before we get started, let's quickly just look at what a Boggle die looks like, because today's mission is to model a Boggle die. So a Boggle die has a letter of the alphabet on it, and notice in all cases it only has one letter, unless of course the die has Q, in which case it has QU on it. So we're going to want to model some special behavior. One of the things we're going to want to do is take our labeled polyhedral die and modify it just slightly to make it even easier to use as a Boggle die. And we're also going to do this to demonstrate some special rules when you're extending classes and sort of clarify some fine points to how the whole thing works. So, how is a Boggle die different than a labeled polyhedral die? Well, really the only difference is that a Boggle die always has 6 sides, and it is only has one letter on it, unless that letter is a Q, in which case it always gives us QU. So what we're going to do now is we're going to write that special Boggle die, and we're going to do this by creating a new class, which will be called a Boggle die. And our Boggle die, as we've already said, is going to have some special behaviors. So let's outline what we want those to be. A Boggle die always has 6 sides and only one letter of the alphabet on each side, unless the letter is a Q, in which case it has QU. Okay, and then we're going to go ahead and identify who we are for posterity. And we're going to mark the version as being the current date, March 4th, 2015. Delete that unnecessary line. Okay, now we've already said that a Boggle die is basically a labeled polyhedral die. So we're going to extend the labeled polyhedral die class, and in so doing, it extends. In so doing, we're going to gain all of the functionality of a labeled polyhedral die. And really, the only thing we're mostly interested in this case is modifying the behavior of a Boggle die just slightly. And the first thing we want to do is make it easier to construct. It's sort of a pain to pass a whole string array to a die when we know that we really only want a series of letters. So we're going to make a constructor for our Boggle die that is a constructor that takes a string that represents what letters we want to put on the sides of our die. Okay, so how would we put the letters on? Well, we always know we want 6 sides, and if the programmer for some reason gives us fewer than 6 sides, we're also going to enforce a special rule that says there has to be 6 sides, and so we're going to arbitrarily say that any side that isn't defined should have a question mark on it. So in order to do that, we're going to start by creating a string array that has exactly 6 sides with a question mark for each side. And that way, if for some reason we're given a die with fewer sides than 6, then we will have a question mark appear instead of generating some kind of an error. Alright, well that's all good. Now what we need to do is figure out how many letters we've actually been given and then put those letters on the sides. Well, what would happen if we had more than 6 letters? So let's write our loop that assigns those letters and then consider what could go wrong. So we're going to say for int I equals 0, I is less than letters dot length, And then we're simply going to use substring to get each letter and assign it to one of our values in our array. So we're going to say ARI equals letters dot substring I and I plus 1. Okay, well, that seems simple enough, but what would happen if we were given 8 letters and our array only has 6 sides? We would get an array index out of bounds error. So how do we make sure that doesn't happen? How do we make our code bulletproof? Well, what we're going to do is we're going to create an integer to keep track of how many labels there are, and we're going to say that it's equal to the number of letters in our string, and then we're going to check and make sure that labels is not greater than the length of our array. And if it is, then we're going to say that labels is equal to the length of our array, therefore guaranteeing that we will only put as many letters as there are in to our array. If there's only 4 letters, then labels will be 4. But if there are 8 letters, labels will be equal to the number in our array. Now, why didn't I actually just put the number 6 here? Because I left my code flexible in case I somehow decide that I want a game of Boggle where there are 7 sides on a die. This will make our code easier to modify in the future, and flexibility is always a good thing. So now I'm going to have my loop only go up to the number of labels. Okay, so I've created my array from my string, and now it's time to call my superconstructor in labeled polyhedral die. And notice in labeled polyhedral die, I have a superconstructor where I pass it a string array to set my side labels. Well, that's great, so all I should need to do here is say super ARR. Now, why do I have an error? And Eclipse helpfully points out for me that a constructor call must be the first statement in a constructor. Remember, the rules say that when you are creating a constructor, you're allowed to use super to call a superclass constructor, but only as the very first statement in your constructor. Well, that creates a bit of a paradox, doesn't it? Because how can I pass an array that hasn't been created yet? And for this, I'm going to leverage a little trick. For example, if I were calling a constructor that took an integer argument, I could do math.random to generate that, or a double argument. I could use math.random to pass a random number to that constructor. Well, I'm going to use a similar trick to create a method that I can call that will convert my letters into an array. So I'm going to create a public static method. Oops, we don't capitalize. A public static method which I'll call letters to array that will take string letters as an argument. And when it is done, it will return a string array. Okay, now I need to fill in the code. Well, where can this code come from? Oh, look here. I can just take all of this code that I wrote here, move it up here into my static method, and then all I need to do to complete the method is I return my array. So, what does this method do now? Well, for starters, it takes a string of letters and it returns a string array where each letter has been assigned to a position in the array up to 6 letters, and if there are fewer than 6 letters, it gives me question marks as placeholders for the missing letters. Now, how do I use that in my BoggleDie constructor? I call the method. Now, recall that when we were calling the math.library method, we would put the class name. So I'm going to put BoggleDie dot. Notice which methods appear here in my list. Only static methods. When I call a class name without instantiating an object. So I've used a capital BoggleDie here, the class name. What methods are available to me from within that class? Only the static methods. And the only static method, other than this inherited method, which we don't want to mess with, is the letters to array method that I just wrote. So I'm going to fill that in. And what is the argument to that method? Well, conveniently, it's letters, which is the parameter that I'm given. So I'm going to leave that alone. And now I've called the super constructor in labeled polyhedral die, giving it an array which I constructed from the static method that is part of my BoggleDie class. This is a nifty little trick. It's definitely a workaround, and it's some highly advanced programming. Now, one last little detail. Do I need to include the class name here? Well, the answer is no, because when I'm calling a method, I'm allowed to call a method within the class that I'm in without including the full qualifier for that class. However, for clarity's sake, I like it, so we're going to go ahead and leave it. And that completes almost everything we need for our BoggleDie. There's just one last exception. What do we do with the special case of the QU? Well, there's a number of ways we can handle this. So let's start with our toString method. We're going to make it so our toString method handles our special case by only returning our get current face. However, we want to intercept the case where the letter on our string is a Q and change it so it actually says QU. So what we're going to do instead here is we're going to say string s equals get current face if s dot equals a capital Q, then s equals s plus u. We'll just tack on a u, and then we'll return s. Now notice in doing this, we've created two different ways to get a value from our BoggleDie. If we use the toString method, it will automatically tack on the Q for us. If we simply use get current value, the inherited method from polyhedral die, it will just return the side label, which should just be a capital letter U. And now we're ready to proceed. Now, one last little detail. Notice that we only checked for a capital Q here, and the rules of BoggleDie say that they should always be capital letters. So if we want to, we can do a little emergency surgery here and make sure that we always have capital letters by adding the toUpperCase method to the end of our substring call. And now we're guaranteed to always have a single capital letter in each of our sides for our BoggleDie. And there we have it, a complete BoggleDie class ready to be used in the next lesson when we create the Boggle board and a Boggle runner to display that board.